Hi, this is Miss Park. This is our first sort of investigation of periodic functions. So hopefully you have a sense already of what a periodic function is. It's something that repeats over time. So we're going to work through this page together. So you can follow here and then please fill in the page in the booklet. So a Ferris wheel at Canada's Wonderland. So here you have a Ferris wheel. It's this ride in the picture, has a radius of 25 meters. It rotates every 60 seconds. Passengers get on at a point that is 5 meters above ground level. So let's explain again. So the Ferris wheel. So the Ferris wheel is a ride, and it's basically it's a circle, goes around. It's off the ground. People get on at some point at the bottom of the ride, and then it turns, and so you go around the ride and come back. So you go around the ride and come right back. Okay, so around and back. So that's a Ferris wheel. Okay, and then it's telling us that it rotates every 60 seconds, which means it takes 60 seconds to go from the beginning all the way around and back to the beginning. Passengers get on at a point that is 5 meters above ground level. So this point over here, if I was to label the heights, this is 5 meters. Okay, and the other thing it says is that the radius of the Ferris wheel is 25 meters. So here, if this is the center, then this here is 25 meters. So this is a 5, and this is a 25. And the radius, of course, is the same all the way around the circle. So let's fill in these blanks, and we'll see what else we need to add to this diagram. Okay, so when t is 0, that is the time that people get on the ride. So it's asking us to put in here, what is the passenger's height above the ground at the following times? So t is 0 when the last passenger gets on at the starting point and the wheel starts to rotate. So this is telling us here what t equals 0 means. So what is the height at t equals 0? So the last passenger is here and we're about to rotate. So what is our height at the very beginning? So that would be 5 meters. Okay, and since the ride goes for 60 seconds and then comes right back to the start, we know that when t is 60 seconds, we are back to 5 meters. Okay, now what's going to happen halfway through the ride? So after 30 seconds. So after 30 seconds, this person is at the very top of the ride. They've gone halfway through. And so what is the height at 30 seconds? Right, so that would be, well, here's another radius, here's another 25, right? So that would be this 5 plus 25 plus 25, so 55 meters. And that's the highest point. That's the highest you could get to. You can't get higher than that. At 15 seconds, we've gone 1/4 of the way around, so we ended up over here. And so what would be our height over here? Right, so we've got our initial 5 plus another 25, so that should be 30 meters. And at 45 seconds, okay, we're at the other side, going around, we're at the other side, and what is the height on the other side? Also 30 meters. So our heights are going to be 5 meters, 30 meters, 55 meters, 30 meters, back to 5 meters again. Okay, and so what happens at 75 seconds? Well, that's again another 15 seconds in the direction that we're going. So we're back to the 30 meters, and so on. And so this is how we have our periodic motion. It's going to repeat. Okay, so let me look down at this graph here, and it's saying plot the values on the graph and continue the pattern to complete the rest of the graph. So you'll see that the graph that is being given here starts at t equals 0 and goes all the way to past 120 seconds. Okay, so 120 seconds is 2 minutes, which means it's 2 times around the Ferris wheel. So the ride is for 2 minutes. Okay, so let's start. When t equals 0, our height is 5 minutes. So I'm going to put a dot over here. And when t is 15 seconds, our height is 30 meters. So I'm going to put a dot over here. And when t is 30, our height is 55 meters. So I'm going to put a dot over here. All right, now when t is 45, our height is 30 meters again. So we'll put a dot over here. When t is 60, our height is 5 meters. So, sorry, I put the wrong one. Okay, I put that dot in the wrong place. Let me fix it. This dot is not there. Okay. So, t is 45, the height is 30 meters over there. So when t is 60, the height is back down to 5 meters. And we have this. We have this kind of shape. And we can keep going because when t is 75, we're back at 30. Another 15 seconds later, so at 90 seconds, we're back at the top of the ride. Then 15 seconds later, we're back in the middle here. And then at 120 seconds, we're back to 5 meters. Okay, and so now we've done 2 full revolutions of the wheel. And so I can connect these dots. So I'm sure with this tool, there is a straight line tool, but I don't know how to use it. So I'm just going to do it freehand. Of course, on a diagram, you would use a ruler, right, to do this. So when you are filling in this page on your worksheet, please use a ruler, not like me. Okay, so now this is saying, is the function periodic? So do we see a repetition of values? So we do, because all of these heights are repeating, right? It's always the same heights again and again. If I did it for another minute or another 10 minutes, I'm going to have the same shape of this graph repeating. So is it periodic? Yes. What is the maximum height of the rider? So maximum height is over here. That's the highest point of the graph, 55 meters. Okay, that's the maximum. And then it's asking what's the minimum? The minimum is down here, 5 meters. How long does it take for the function to repeat? Okay, so it goes from 0 seconds to 60 seconds, and then we're back at the same point that we were at 0. So that means 60 seconds. Okay, and that was given to us in the question because it said it takes 60 seconds to go around. How many times does the function repeat during the span of 2 minutes? So you can see that there's like two, the graph is there twice, the 60 seconds, so twice. If it continues to rotate, predict the height of the passenger when t is 105. So when t is 105 seconds, we can actually read this right off the graph, and we can see that that's 30 meters. Okay, but that's visible already from the graph. But now what if we're being asked for something past the graph? So we have to predict. So after 180 seconds, where will we be? So we know that for every 60 seconds, after every 60 seconds, we're back to 0. So if we start at 0 and we go for 60 seconds, we're back at 0. So if we go for 180 seconds, it means we're going to go 60 seconds 3 times. So we are back at 0, which is the 5 meter height. If t is 210, well, we know that every 60 seconds, we're back to the same height. So I can take 210 and subtract 60, and I get 150, but I can actually even subtract 60 again. I can actually even subtract 60 again. I can keep subtracting 60 until I get a value of seconds that is in the first cycle. Remember, we talked about a cycle being the thing that's repeating. 210 seconds would be the same height as 30 seconds, because every 60 seconds, I'm back to the same location. So hopefully this is starting to look a little bit familiar from our previous unit on trig, because there was a concept just like this, where we end up in the same place. So I'll let you think about it. Okay, so where were we at 30 seconds? Well, at 30 seconds, we were at our maximum, so 55 meters. Okay, so 200 seconds is the same as 30 seconds, same height. 405, so let's take away a bunch of 60s. I can take away 360, so I can take away 6 60s, and I'm left with 45 seconds. So whatever the height is at 405, it's the same as whatever it was at 45, which is 30 meters. Okay, 1095, same thing. Take away a bunch of 60 degrees, right? You can use your calculator, and I think we can take away 10 of them. Oh, more of that. 10 of them would be 600. So I could take away 10 60s. That would give me 495, but I can actually take away more than that. I can take away 8 of them, another 8. So that would be 480. So I can go 495. So you can use a calculator. I'm just sitting without a calculator, so I'm just using my mental math. I can take away another 8 60s and end up in the same place, and that gives me 15 degrees. 15 seconds, sorry, 15 seconds. And so 1095 seconds will land me in the same place as 15 seconds would. So here's my 15 seconds, 30 meters. And finally, 1 hour. Well, every minute I'm back to the start, right? I start at 0, and every minute I'm back to 0. So at the end of exactly 1 hour, I am back to 0. So this is the same as t equals 0, and the height at t equals 0 is 5 meters. All right, let's go a little bit further down here. I'm going to go to the second page and go back to some of those key terms that we talked about in the introduction, and also some other terms. Okay, so periodic functions have key properties, and these are huge in our unit, and that's why they are underlined, because we will be using them for every problem. So the domain and range of the function for a 2-minute ride on the Ferris wheel, you can see domain and range right from the graph. So we can see for 2 minutes, our time goes from 0 to 120 seconds, and our height goes from 5 meters to 55 meters. So let me write the domain and range over here. So domain. So the domain is the set of all t's such that t is between 0 and 120, and t is an element of the real number. So that means anything in between is okay. And the range is the set of all h's such that h is between 5 meters and 55 meters. And h is an element of the real number. So all times and all heights are valid within those ranges. What does the word cycle represent for the Ferris wheel situation? So the cycle is 1 time around the wheel. So that at the end of the cycle, you come back to exactly where you started at the beginning of the cycle. Oops, sorry. 1 time around the wheel. What is the period? So the period is the length of the cycle, how long it takes. So it takes 60 seconds to complete the cycle. What is the difference in height between the highest point and the lowest point, okay, of the Ferris wheel? So if we look at the highest point, it's 55 meters. The lowest point is 5 meters. So what's the difference in height? So that's 55 meters minus 5 meters, which is 50 meters. New word, amplitude. What is the amplitude of the function? So the amplitude means, another word for amplitude is half height. Okay, so what is the half the height? So if the height is 50 meters from the previous one, therefore the amplitude is 25 meters. Okay, so new word amplitude, I'll put a star. New word amplitude. And what does the amplitude correspond to with regard to the Ferris wheel itself? What was 25 meters? Where did we see 25 meters? Sorry for the bell. So what was 25 meters? That was the radius of the wheel. Okay, so this is the radius of the wheel. What is the average height of the rider? So what's the average? Well, the lowest is 5 meters. The highest is 55 meters. So what's in the middle? So let's do that. So the average is going to be, I'll take the lowest, which is the lowest and the highest. So I'll take the max plus the min, and I'm going to divide them by 2, right? So that's going to be, the maximum was 55, the minimum was 5, divided by 2. And that's going to be 60 divided by 2, which is 30 meters. And that makes sense because that's where we were. The average height is over here at 15 seconds, and at 45 seconds, that was halfway between the lowest and the highest. Okay, okay, what else? Oh, let me just go back to amplitude for a second. So the difference in height, is how I got it, is the max minus the min. So another way to think of amplitude is that because it's half the height, it's max minus the min divided by 2. Okay, so now we have a kind of formulas, but if you understand, you don't need the formulas. And what is the equation of the axis? So the axis is the horizontal line that goes through the average. So we said the average was 30. So the axis is this line here. I'm going to draw it. And this is called the axis. And another word for axis is midline. So I'm going to write it over here. So axis is the same as midline. And midline, the word midline means a line that goes through the middle. And so we know that the average is 30 meters. So all it is we have to write it with the equation, h equals 30. It's an equation of a line. Okay, now these think ahead, we're going to discuss them in class. So I'm going to leave it right here. Have a look at this. Think about the think ahead. And it's asking what would be different if we change something about the Ferris wheel. So this will be our first discussion when we come together on this. Okay, and thank you for watching.